Good day students. In this video I will show to solve some questions from chapter 12 progressions 12.2 geometric progressions. Determine whether each sequence below is a geometric progressions GP. Okay, we start the first one. A 7, 21, 63, 189. So if it is a geometric progression, the common ratio should be the same. So how to test the common ratio? We divide, let's say I take the second term T2, divide with the first term. You must divide with the term before the second term, that is the first term. If you take the third term, then it becomes the second term. So T2 over T1 is 21 over 7, and then you get 3. So we test again with different terms, maybe T3 over T2. T3, the third term, is 63 over 21, and this is also equals to 3. Okay, so I can write, since R common ratio is equals to T3 over T2 equals to T2 over T1. Therefore, this is a geometric progression GP. Okay, can move on to the second question, B. Okay, the same procedure as I did A. So we'll divide T2 and T1. So that will be 3 to the power of negative 2 divided by 3 to the power of negative 1. Same number, the index is different. So what you can do when you divide, you just minus. So this is 3 to the negative 2 minus negative 1. Then you get negative 2 plus 1 is negative 1. Okay, so I'll divide again the third term and the second term. Third term is 3 to the negative 3 over 3 to the negative 2. So when you divide, you minus the index, the power. So negative 3 minus negative 2 becomes plus 2. Negative 3 plus 2 is negative 1. So you see the ratio is the same. 3 to the power of negative 1, 3 to the power of negative 1. Even though you divide different terms, that means this is a GP. So I can just can also write since I can just follow this, R equals to S as above, or I can just straight away I can write there, this is a GP, geometric progression. Okay, it's better to write a description like this, but since we have done that in the first question, so for the second question I'm just writing straight away, but it's better to write down the full description. Okay, we move on to the third question, C. Same process, T2 divided by T1. What is our T2? 4 to the power of n divided by 2 to the power of n. This becomes 4 is 2 to the power of 2, and that is n, so we just combine, multiply, comes to the power of n. So same number, index is different. When you divide, you minus 2n minus n is n. Okay, move on to the next one, T3 over T2, 6n over 4n. Okay, 6n over 4n. Okay, to divide 6n over 4n, what I can say is that you won't definitely get 2n. Okay, 6 divide, this is not a base 2, 6 is not a base 2, so it's difficult for you to get. I mean, what you can do is like, okay, I'll simplify this. This is 3 times 2 power of n. This is 2 to n. Okay, so 4 is 2 to the power of 2, then multiply then becomes 2n. 6 is 3 multiplied 2, so we get 3n 2n 2 to the power of 2n. So we got this. You can simplify this, just write here, hopefully you can see. Yep, so this is 3 to the power of n times 2, n minus 2n is negative n. So can you see that the ratio, when you find the ratio through T2 over T1 is not the same with the ratio that you find through T3 divided by 3. The ratio is not the same. So when the ratio is not the same, you can say that this is not a GP. This is not a geometric progression. This is not a GP. Why? Because the ratio is not the same. It is a geometric progression when only the ratio is the same. You take two different terms and divide them. Moving on to question D. Hope you can see. Yep. So question D, same process, T2 over T1. T2 over T1. Question D is 4p square over 3p. 4 over 3 p square, same number, the index can minus 2 minus, this is 1 actually, so 2 minus 1 is 1, so you get 4 over 3 p to the power of 1. 2 minus 1 is 1, and for 1 you don't need to write that power, the index. So we move on to the second process, 3 over T2, 5p cube over 4p square, you get 5 over 4, index you minus since it divide, so you get p to the power of 1, it's no need to write. And if you see, the ratio is different. When you divide different terms, you get different ratios. That means this is not a geometric progression. Okay, and okay, last one, E. T2 over T1, 2m plus 4n over m plus 2n. This one I can just factor 2 out. I get m plus 2n over m plus 2n, and simplify, I get 2. Okay, I'll do the next one, T3 over T2. And what is T3? It's 4m plus 8n over 2m plus 4n. I can factor 2 out. I get 2m plus 4n, 2m plus 4n. Then I can simplify, and then I still get 2. Since the ratio is same, it is common, so this is a GP. This is a geometric progression. Okay, so that's the answer. Just put a asterisk to show that, show the examiner that this is the final answer. Okay, moving on to the next question. Okay, hope you can see. Given a geometric progression 6, 3, 3 over 2 and so on, find the 8th term of the progression. Okay, find the 8th term. That means they ask you to find T8. T8 is the 8th term. The formula is a r to the power of n minus 1. 8 minus 1, and you get a r to the power of 7. And what is your a? Your a is the first term, that is 6. R is your ratio, common ratio. So to get your common ratio, you just divide T2 and T1. Okay, so you get 3 over 6 to the power of 7. That becomes 6. You can simplify, it becomes 1 over 2 to the power of 7. 1 over 2 to the power of 7, you can use calculator to get the answer. 1 over 2 to the power of 7 equivalent to 1 over 128. So you get 1 over 128. You can simplify this. You can multiply 6. You get 3 over 64. 3 over 64. That is the answer, the 8th term. Okay, move on to the next question, B. The nth term of the progression, the nth term. That means the formula is Tn equals to AR to the power of n minus 1. And what is your A? We know the A is 6. And what is your R? We know the R is 1 over 2. We have done that in the question A. And use that 1 over 2 to the power of n minus 1. Okay, this will be the answer for the n term. Okay, n term. You can't simplify the 1 over 2 and 6 because it's in the bracket and you have a index, you have a power here. Okay, moving on to the next question. Okay, hope you can see the question. Yeah. A geometric progression is given as 4x, 8x, 16x and so on. Find the 12th term of the progression. Okay, the 12th term is T12. The formula is AR to the power of n minus 1. Here it's 12. 12 minus 1 is 11. Your A is 4x. Your R is 8x over 4x to the power of 11. So get 4x. This one you simplify, get 2 to the power of 11. Multiply this. So 2 to the power of 11, what's the answer? We can use the calculator. 2 to the power of 11, it's 2048. So it's 4x times 2048 and you multiply with 4, get 8192. So it's 8192x. That's the answer for 12th term. And the second question is, which term of the progression is equal to 512x? Use the same formula. Tn equals to AR to the power of n minus 1. In this question, we know the Tn. The Tn is 512x. So it's, you can see, yeah, it's 512x, 512x. A is 4x. R is, we know the R, it's 2. We know the R from the first question, 2. Okay, we don't know the n. We need to find the n, so it's n minus 1. Okay, I can cancel the x. I can switch places. So it's 2 to the power of n minus 1 equals to 512. And there is a 4 here. So what I do with the 4, I bring it here, becomes divide. So 512 over 4, it's 128. So 2 to the power of n minus 1 equals to 128. Now you need to find the value of n, but your n is the index in the question. So how to do that? There are two ways. One difficult way, not to say difficult, but it's more steps, and the other one a simple way if you can figure out some things. Okay, I'll show you the difficult way, I mean the more steps way, the way that involves more steps. Okay, so to find the n, you have to take log both sides. Take log base 10 on both sides. Remember, you must write this down to show the examiner what you're doing. So when I take log 10, it's log 10 2 to the power of n minus 1 equals to log 10 under 28. So take log 10 on both sides, and when it is a log, the index can be brought forward. So it becomes n minus 1 log. Okay, log 10 can be written as lg log 2. This is lg 1 to 8. So just leave n minus 1 here. I'll bring lg2 over to my right. So lg 1 to 8 over lg2. So I'll use the calculator to solve this. It's lg 1 to 8, so it's log 1 to 8 divide by, again, log 2 close bracket equals to 7. Okay, this is 7, so n is 7 plus 1, that is 8. This is a way of doing it using log. Another way of doing it, maybe slightly shorter way, I'll show it here, is to guess if 128 is a base 2. Okay, that means if you can guess that 128 is actually 2 to the power of 7. If you can guess that, you can make your steps shorter. So if this is the case, the base is same, therefore the index also must be the same. You can use the therefore. This is the symbol for therefore in advanced. So therefore, since the base is same, you can equalize the index n minus 1, so 7, so n equals to 7 plus 1, you get 8. Same answer as this. That's all for the class. See you in the next video.